Okay, guys, today we're going to find the surface area of pyramids and cones. This is going to work very similarly to what we did yesterday, where essentially we're just accounting for the area of each face of the shape. So we want each face of the shape. So we talk about different faces. One face that we have is a face that we call the base, okay? And so the base is right here. It's the one face on the polygon that's of the pyramid that's not a triangle. Okay, and sometimes it can be a triangle, but it's that base is right there. Okay, and essentially what happens is from each vertex on the base, we have edges that go up to a single defined point. And so each of these faces on the side that we call lateral faces, each of those is going to be in the shape of a triangle. And in fact, all of those triangles are congruent. So if you found the area of just one triangle, then you could just multiply that by how many you have. Now, so again, those are called lateral faces. And then, of course, we have the base. You also have a lateral edge, which are kind of what I highlighted in black there. And you also have base edges, which are down there with the base. Pretty self-explanatory. Now, one thing that is very important to note, something that's very different, and this is going to go into next week's lesson too, is the difference between altitude, which is how tall that pyramid is at a right angle, and what we're going to call slant height, okay? So you have height and you have slant height. So here in this picture here, slant height is kind of the altitude of this triangle. That is going to be a very different number than the actual height of the pyramid, all right? So H is height, L is slant height. And you could tell just by connecting those and making a right triangle that in a right triangle, the hypotenuse is always longer. So the slant height is always going to be longer than the actual height. Slant height versus height or altitude is an important distinction to make. Now, we talked early in the year about making nets out of our shapes. You know, imagining taking a shape and unfolding it and laying it flat. And so the way that we can find the surface area of a pyramid is pretty straightforward. To find the surface area of a pyramid, we need to find the area of that base. So we need to find the area of that base. In this case, it's a square. Sometimes it's different shapes. And then add to that however many triangles we have times the area of one triangle. So you'll see up here it says the lateral area would be each of these shapes. So each triangle would be 1/2 times the side length times the slant height. Not the actual height, but the slant height. And then you got to multiply that by the number of triangles that you have or the number of edges that you have. Let's take a look at an example. Okay, guys, so here we're looking at example 1. We don't have a picture, so I drew a picture real quickly of a square pyramid. And it says each of the base edges is length 5, and the slant height is 3. Now, one way of doing this is you could just draw the net. And if you think about what we did earlier in the year, if I were to draw a net of that shape, I would have a square plus the 4 triangles. And so now it's just a matter of looking at the length. What did they say the base edge was for the square? Well, it's a square that's 5 by 5. So square is just base times height. 5 times 5 will get me 25. Plus I have 4 triangles. Well, what's the area of a triangle? 1/2 the base length, which they said was 5, times the slant height. The slant height is 3. So I'll do 25 plus 3 times 5 is 15, times 4 is 60, and half of that is 30. So it's a total of 55 square meters. So now we're going to take a look at example 2, and this one's a little bit more complicated because it's a hexagon, first of all, and secondly, they don't give me the slant height. Remember, the slant height is this distance from the vertex to the midpoint of the edge. It's not 42. 42 is not the slant height. That's the actual height. So let's think about what this means. First of all, if I did a net without doing too fancy here, I would have a hexagon plus 6 triangles. So I'd have a hexagon plus 6 triangles. Okay, well, what's the area of a hexagon? Well, the area of a hexagon is 1/2 times S times A times N plus the 6 triangles. That would be 6 times 1/2 the base times the slant height. So now I've got all these little pieces that I need to find, all these little letters. Well, what's the side length? They give me that. That's 36. What is the apothem? They give me the apothem. The apothem is 18 radical 3. What are the number of sides to a hexagon? 6. Plus 6 times 1/2. What is the base of a triangle? Well, the base of one of these triangles is just 36. But what's the slant height? What's that in blue? They didn't give me that. They gave me the apothem and the actual height, but they didn't give me the slant height. So what you have to do is you have to use the Pythagorean theorem here. If the apothem is 18 square root of 3 and the height is 42, what would the slant height be? So I would have to do 42 squared plus 18 radical 3 squared equals slant height squared. I'm going to use my calculator for that and get 2736 on the left equals L squared. So L equals the square root of 2,736. That is slant height. The square root of 2,736. So now I'll put these into my calculator individually. Be careful when you put these in. I'll put this first one in. So for the first one, I will get 3,367.106 plus, in the second one I get 5,649.13. 3, and when I add those together, I get a total of 9,016.24 square feet. That one has some tough math in it. We have to find the slant height. We get some kind of crazy numbers there with the radicals, but hopefully going through that once helps. Sometimes you'll use Pythagorean theorem. There could even be one on a SAT or ACT where they actually, instead of giving you, you're going to need the slant height, but they might give you kind of an angle down here or an angle up at the top. And given an angle, you would have to use trig instead of the Pythagorean theorem. But for what we're going to do, we're just going to need to use the Pythagorean theorem. Okay, guys, now moving on to cones. Cones are very similar and their structure to pyramids. The only difference is instead of the base being a polygon, the base is a circle. So a cone is a solid that has a circular base and a vertex, not in the same plane. In a right cone, it is straight up and down. In an oblique cone, the vertex is not directly above the center of the circle. And then, once again, slant height is an important thing. Slant height is something that is a different distance than the actual height of the cone. Those are different things. For surface area, we need slant height. So, without getting into any crazy detail, but we have two parts of this cone that we need to find the area of. One thing we need to find the area of is the base. Well, the area of the base is pretty easy. The area of a base is just pi times r squared. The thing that's tougher is all of this lateral area. So from the vertex down all around, kind of the side of the cone. If you think of an ice cream cone, the actual part that makes up the ice cream cone. How do we find that area? And the formula for that is pi times the radius times the slant height. Remember, that L there is slant height, not the actual height. So pi r squared is the base, plus pi r L is the lateral area. And so together you get this formula. The surface area of a cone is going to be pi r squared plus pi r L. Some guys like to factor out the pi r, and they do pi r times a quantity r plus L. But I don't like this shortcut all the time because sometimes you have basically a cone without a base. So I just like to have the first one memorized because that is the base of the cone and that is the lateral area. Let's look at a couple examples. What's great about cones, guys, is it's pretty much a formula. Let's take a look. For example 3, surface area. Surface area is going to be pi r squared plus pi r L. Pi times the radius is 15, 15 squared, plus pi times the radius is 15. The slant height is 25. They've given me everything, guys, so now it's just a little bit of calculator work. I do that calculator work, guys, and I get 225 pi plus 375 pi, and that's a total of 600 pi centimeters squared. So there's your answer. If you want that in terms of, if you want to round it out to the nearest tenth or the nearest hundredth, you would do 600 times the pi button on your calculator. Don't just use 3.14 because that's not enough in terms of accuracy. So use the actual button on your calculator and then round in your final step. So 600 pi centimeters squared is the answer to that one. Another thing that's nice, guys, about having the formula is, you don't have to draw the picture if you're just looking for certain things. You're looking for the radius and you're looking for the slant height. Now, it could be that you get a cone where they don't give you the slant height, right? Maybe they give you the radius is 16 and the actual height is 20. And so maybe you got to use the Pythagorean theorem to find the slant height. I didn't make you go through that step on this one because we did that in example 2, but that's totally possible. Sometimes they don't give you what you need. In this particular setup, they gave us exactly what we needed. We needed the radius and we needed the slant height. Another possibility is they give you the diameter instead of the radius. Well, if they give you the diameter, just cut that in half to get the radius. Either way, since it's very much just a formula, the radius here is 16, so it'll be 16 squared plus pi times 16 times, they told me the slant height was 28. And so I do this math in my calculator. And so I'll end up getting 256 pi plus 448 pi. And that'll be a total sum of 704 times pi meters squared. Again, if you put that in your calculator and you want to see what that is exactly, put in the actual pi icon. That would be approximately 2,211.68 meters squared, right? And that's the answer. Hope that helps, guys. That's all for today. We're done with surface area, and then tomorrow we start on volume. Volume will be a totally different thing, so look forward to teaching you tomorrow.